All right, honors stats. This is chapter 10.2, dealing with inferences about the difference of two means, which we're going to call mu1 and mu2. All right, so there's four different things that we're going to do in here. Two problems when sigma is known, or both sigmas are known, and you need to know that sigma is the population standard deviation. And then we're going to have two problems to do when sigma is not given, which means you're going to have to use S, which is the sample standard deviation. We're going to do hypothesis tests for both and find a confidence interval for both. So here's our first example. The pathogen Phytophthora capsicum causes bell peppers to wilt and die. Because bell peppers are an important commercial crop, this organism has undergone a great deal of agricultural research. It is thought that too much water aids the spread of the pathogen. The two fields are under study. The first step in the research project is to compare the mean soil water content for the two fields. Units are percentage of water by volume of soil. So we have two different fields. They have nothing to do with one another, and that's what we're dealing with, the differences of our population means mu. This is the hardest question you can have. Why is it hard? Is because they're giving you the sample data. As soon as you get or are given the sample data, that means that you're going to be using sample standard deviations, which are denoted by S. So what you're going to have to do first is you're going to have to use your calculator, and you're going to have to find X bar and S for the first set of data, which we're going to call X bar 1 and S1. Continuing with your calculator, you're going to find X bar, the mean, and our sample standard deviation for the second set of data, which we'll call X bar sub 2 and S sub 2. Remember, this is where you hit stat on your calculator, plug the data pieces in, and it'll give you your numbers, your answers, okay? Understand, 2, 4, 6, 8, 10, 12, 14, 2, 4, 6, 8, 10, 12, 14, 16 in the set. Now, our questions, okay? First of all, question A. Assuming the distribution soil water content in each field is mound-shaped and symmetrical, which means it's normal, we're going to ask you to use a 5% level of significance to test this claim that field A has on average a higher water content than field B. A higher than B, which is a greater than problem. We'll come back to question B in a moment. That's our last question. Because it said field A has a higher soil content than B. And understand, remember field A was data 1. Sure, unit set. Back, we're dealing with a 5% level of back, and that's this question here. We're going to find a 95% confidence interval for mu1 minus mu2. So the first thing I'm going to ask you to do is use your calculator and find each of those values that I talked about before. So I've already done so, and we get 12.53 for X1 bar, 2.39 for our sample standard deviation of that first soil data. This is 10.77, that is X sub 2 bar, and 2.40 is the standard deviation of your second set of data, okay? So all of these guys are found by calculator. Now, our hypotheses. Every single null hypothesis in 10.2 is mu1 is equal to mu2. You're going to assume that the two population means are equal. Now, if they're not equal, this is what your claim is. And if we go back, and let me start the alternate hypothesis. The alternate hypothesis always has to have mu1 first and mu2 second. You have three choices. You can put not equal to if it was a different question. You can put less than if it's a less than fewer question, or in this case, a greater than. And let me go back and show you why it's greater. So basically they're saying data 1 is greater than data 2, okay? In this case, the means. So now we know we have a one-tell test. So, test statistic. In chapter 10.2, you have two test statistics, either Z or T. Ladies and gentlemen, if you are given S or find S, which is your sample standard deviation, your test statistic is always T. Formula, you have to memorize. It's X bar 1 minus X bar sub 2 over a big, huge square root of S sub 1 squared over N1 plus S sub 2 squared over N sub 2. So let's plug in our numbers. 12.53 is your X1 bar. Take away 10.77. Now, knowing that difference is going to be very important. So when I subtract, I get 1.76. We're just going to let that sit there for a little bit. That's the numerator, just so you guys know. Now, the denominator is going to be the 2.39 squared over, and if you count the number of pieces, there were 14 data pieces. Okay, so N1, 14 is the number of data pieces in the first set. Now we're going to take our 2.40, square it, and divide it by that 16 that I just got. If it's a T, you should know you go to 3 decimal places. This yields 2.008. 2.008. That, ladies and gentlemen, is your test statistic. Now, next question. Find the p-value. Understand when you have a t-score, we need a couple of things. We need our degree of freedom. Ladies and gentlemen, degree of freedom is always going to be n minus 1. And not only you need to know that, you must use the smaller n, not the larger. So, since 14 is smaller, our degree of freedom for this example is going to be 14 minus 1, which is 13. So your job is to go to your T-chart and look up 2.008 with a degree of freedom of 13. In doing so, you'll have a 1771 that's smaller and a 2.160 that's larger. This yields a p-value of 0.5. This one yields a p-value of 0.25. We've done this many a times. Now, we're actually dealing with the interval between those, so let's get the average, which is 0.375. This is not the true p-value, but it will help us with the level of significance. So what you're going to write is you're going to write p-value 0.0375, and if we go significance, so I'm going to compare it to 0.5, and we hopefully see that it's less than. If it's less than, your conclude is simply going to be reject H naught. If it was a greater than, you would write fail to reject H naught. So I only need a few words on that answer. Now we're going to interpret. Since there wasn't set, we're going to write these words. The population, mean soil water content is higher in field A. All right, and remember, if you reject, you're rejecting their equal. If you're rejecting your equal, that they're equal, then the population means, or what the claim said, one is larger than the other. And that's what we wrote. Population mean soil water content is higher in field A. And now we're going to answer the last question. So first let me show you the formula for this. mu1 minus mu2 has to be in between your x1 bar minus x2 bar plus our margin of error and our x1 bar minus x2 bar minus our margin of error. Now do you see why I did that 1.76, 12.53, take away 1.76? Okay, so we now know that this is going to be 1.76 minus E, mu1 minus mu2, and 1.76 plus whatever E is. Now we have to get E. E, ladies and gentlemen, by formula, is a critical value for T times that same old big square root, S1 squared over N1 plus S2 squared over N2. Remember, any T, you're going to have to use the chart again. So we're going to go degree of freedom of 13. And since it's 95%, we're looking up 0.95. And all you have to do is just go down 0.95 and over 13, and you will see 2.160. Okay, so this number comes from your T-chart. This is still the 2.39 squared over 14, 2.40 squared, sorry about that, squared over 16. Plug it all in your calculator and I get 1.89. So we're going to subtract the 189 and we're going to add the 189. So my interval goes from negative 0.13, the difference of mu1 and mu2, and 3.65. Let's write that one more time in our answer line. mu1 minus mu2 and 3.65. So while I have the video, let's just talk real quick about this. So, being that you have one negative and one positive as the bookends of your interval, basically what it's saying is this. If it's positive, mu1 is larger. If it's negative, mu2 is larger. Well, we don't know which one it is, so all you know is either mu1 or mu2 is larger. Who cares? That's our interval, okay? So let's reiterate the first type of question. If you are given or you find S's, not sigmas, S's. S's are sample standard deviations. Your test statistic is going to be a T. You're going to use your T chart to find your p-value. You're still going to reject or fail to reject depending if that's less than or greater than. You're going to interpret, and then you're going to find a confidence interval, again, using our T, using our chart, and then the formula that you memorize. That is the first type of question. Here comes the second type of question. A random sample of 49 measurements from a population with a population standard deviation of 3. Ladies and gentlemen, that is sigma 1. These are not S's, they are sigmas. It had a sample mean of 10. That's your X bar 1. An independent random sample of 64. There's our next N from a second population with a population standard deviation of 4. Again, that is sigma sub 2. Had the sample mean, which is X bar sub 2. Remember, this one is X bar sub 1. And our claim. We're going to test a claim that the population means are different. That means in our alternate hypothesis, we're going to use not equal to, and we're going to use a level of significance of 0.1. So notice this problem gave us everything. The problem we did before gave us data pieces. Back and get our significance level, which is 0.1. So here we go. Let's write both hypotheses. Again, the first hypothesis, everybody, is always the null hypothesis. mu1 is equal to mu2. The alternate hypothesis is mu1 does not equal mu2 because of that word different. It could have been greater, could be less, it's different. Now, memorization, guys, since sigmas were given, we're using a test statistic of z. Now, the form is very similar. It's still going to be x bar 1, take away x bar 2. We're still going to have a big old radical on the bottom. We're still going to have the same two fractions. It's still going to be n1 and n2. But instead of s sub 1 squared, it's sigma sub 1 squared and sigma sub 2 squared. So very similar formula. So remember the x bar 1 was 10, the x bar 2 was 12. Remember that negative 2 is going to be used later in your confidence interval. Your sigma 1 was 3. We have to square it. And remember there was 49 data pieces. Your sigma sub 2 was 4. Square it. And remember the second had 64 data pieces. Remember it didn't say anything about normal? Well, both of those ends are bigger than 30. Therefore, the central limit theorem takes over, so we're good. Squiggle, squiggle. Remember, if it's a z, it's going to be 2 decimal places. In this case, negative 3.04. Now, finding a p-value is not the same with z. You guys, for z, have to draw a standard normal curve. Negative 304 is right here. But remember, since it's not equal to, it's a two-tail test, so you have to also do positive 304. Looking up on your z-score chart, this little piece right here is 0.0012. So since it's symmetrical, this is also 0012. Our p-value then, ladies and gentlemen, is the addition of those two together, which is 0024. Let's go 0.01, and this is also smaller. So therefore, if it's smaller, we still are going to reject H naught. Okay, so I didn't do an example where it was larger, where you failed to reject, but it's okay. You have done many, many of those in the past. So since this one doesn't have any set things, it didn't talk about population, soil, and water content, you simply have to say the population means are different. All right? So if we reject this guy here, that means this guy is true. That means the alternate is the means are different. And let's finish it off with a 90% confidence interval. Ladies and gentlemen, we still have to find E. In this case, we're going to use a Z sub C, and we're still going to use that crazy formula, sigma 1 squared over N1, sigma 2 squared over N2. Please remember that this Z of C is your memorization. I'm going to say them now. 90% is 1.645. 95 is 1.96. 98 is 2.33. And 99 is 2.58. So since this is 1645, we write it. Over here, we still got the 3 squared and the 49. We got the 4 squared and the 64. Plug it all into our calculator, and we get 1.08.
99 was 2.58?
99, 2.58, yes. So remember before, we had our x1 bar minus x bar, x2 bar, which we already know is negative 2. So this one is going to be negative 2 take away the 1.08. Here's the mu1 minus the mu2. And negative 2 plus 1.08. So this yields a negative 3.08, mu1 minus mu2, and a negative 0.92. So let me write it on the answer line, negative 3.08, mu1 minus mu2, and negative 0.92. So if we look at this guy carefully, and we're going to talk about it a little bit here, if you see that both are negative, that means that mu2 is always going to be larger. Okay, remember the one we did before? We had one negative and one positive. You don't know about mu1 and mu2. Let's talk about if they were both positive. If these were both positive, then mu1 would always be larger. Okay? But for our purposes now, for this example, since they're both negative, mu2 is larger. And guys, if mu2 is larger, doesn't it mean that they're different? Yes, they do. So it's kind of verifying what our hypothesis was before. Okay? So, one more reiteration of each of these. Ladies and gentlemen, if sigma, that's an ugly sigma, if sigma 1 and sigma 2 are given, you are going to use the z as your test statistic. If they are not given, that means that S1 and S2 will be given. And if they are given, you're going to use T as your test statistic. Okay? The set formula for each of those, okay, is going to be what? X bar 1 take away X bar 2, the square root of two fractions. This is N1, this is N2, and this is going to be sub 1 squared and sub 2 squared, and it's either the sigma or the S. Sigma or S. Okay, so it's the same formula to find our Z or T. Okay, all you're doing is replacing sigmas and S's. Okay, so ladies and gentlemen, that is chapter 10.2. Test is Wednesday.